So what we have done now is we have inserted these rods so that we can place the T-shirt, which has a little pinhole inside, so that we block most of the light and find the center spot on the DMD. So now the crucial part will be to find the right angle of this mirror so that we point on the DMD's center. For this we have removed the lenses of the telescope here and will now turn on the first laser. So this is our magic trick where we have a collimator laser diode mounted in a mount that is now being set up on the microscope as a SM1 thread, and we will now change or adjust the distance between the tube lens that we insert in the tube of the Nikon stand and the telescope that is necessary to block the zeros order and the DMD. So, and for this I will first insert the mount here in the microscope, and the mechanical part ensures that the laser is parallel to the optical axis or centric to the optical axis. So once this is inserted, we have to make sure that laser safety is ensured so that there's no reflecting element in the way. So now it's in there, and the beam path will go through the infinity path, and here we inserted the Thorlabs tube lens that can be buried in X and Y, and then we have to form an image in that plane roughly, so that the next lens from the telescope is then collimating the light before it goes through the tube lens, the Fourier mask, and then being imaged on the DMD. Yes. Okay, so we will now insert the power plug and then observe the focus of the laser. And so we expect the laser pointer to be here. So switch off the light to see it a bit more closely. And so the focus will be there where the speckling will be the largest, so somewhere here. So now that we've turned on the laser, we will see the focus spot right here, and you already see while you move the laser along the optical axis, the screen, that there's two focus points that comes from the fact that we have a dichroic that's having two reflection because it's not optimized for the wavelengths of the alignment laser. So then here you have the focus. We would expect the two spots coming here all the way through, staying roughly same distance, which means we are perfectly in infinity space. And then here we'll have another picture or like the focus spot on the DMD. And if this is maintained, then the optical axis and the distances of the different elements are met. So now that we've turned on the laser, we'll see the focus spot right here. And you already see while you move the laser along the optical axis, the screen, that there's two focus points that comes from the fact that we have a dichroic that's having two reflection because it's not optimized for the wavelengths of the alignment laser. So then here you have the focus. We would expect the two spots coming here all the way through, staying roughly same distance, which means we are perfectly in infinity space. And then here we'll have another picture or like the focus spot on the DMD. And if this is maintained, then the optical axis and the distances of the different elements are met. So if for whatever reason the spot on the DMD is too far away from the DMD or not focusing quite enough, you have to move the entire telescope, since we already aligned that by placing the infinity source in that plane, so that we were making sure that this lens here is focusing on the Fourier plane, and then from here it's being transferred back to infinity with this lens. So the distance between this and this lens is roughly twice the focal length that's being 100 millimeter from the principal plane here to the principal plane there. So for the next step, we will turn off the alignment laser, and then we'll remove the telescope lenses so that we'll be able to track the infinity path from the two different lasers through the tube lens, so that we end up in the back focal plane of the microscope. And then for this, it's important to place a small aperture between the collimating lens and the DMD, so that it's easier to find the centrum on the DMD and then later in the sample plane as well. So what we have done now is we have inserted these rods so that we can place the T-shirt, which has a little pinhole inside, so that we block most of the light and find the center spot on the DMD. So now the crucial part will be to find the right angle of this mirror so that we point on the DMD's center. For this we have removed the lenses of the telescope here, and will now turn on the first laser. Okay, so now it's important that the laser on the DMD here is in the center, which right now it's not, so the laser beam is reaching the DMD too high. So you have to change the mirror's position right here, so that the laser beam is in the focus or in the center. Now it's important to switch on the DMD so that the mirrors are in the active on state, so that the beam is not deflected in the off, but going through the Fourier filter planes, so that you in the end will have a central spot in the center of the tube lens that's going inside the microscope. And here we see that the laser is not yet in the center, so we would need to move the screws of the DMD, and for this it's quite advantageous that it's mounted on a kinematic mount, so that we can move the beam spot in the center of the tube lens. So now what we have managed is the laser here is being collimated by this lens here. Then we have a T-shirt that is blocking most of the light, forming a small beam with a small diameter, hitting the center of the DMD here. And then we have tuned this angle so that we'll reach the center of the last T-shirt before entering the microscope. So now it will be the same for the red, so that we turn on the red light and then tuning mostly this mirror so that we end up in the center position of the DMD, and then tuning the same angle so that we enter the center of the t-shirt that is reaching the microscope. So for this we enter now the t-shirt on that side, then we'll see a small spot over here, which is deflected on that mirror, and then we'll have a small spot in the center of the DMD, which we can illustrate again with a little paper, and then we'll eventually reach the center of the final t-shirt over there. So we only need to change the position slightly. Okay, so now that we have adjusted the red and the blue light individually, it's now up to aligning both so that they end up in the center of the DMD. For this we'll then take two of the shirts, creating small beams that are then being reflected in the center, hopefully, of the DMD, which is almost the case. So we would just need to move one laser slightly.
So?
Yeah. Now in complete darkness, since we have only turned on the red and the blue light, it's now up to us to spot the light that is going out from the infinity path, and we have to make sure that, for example, at the ceiling, the two beam spots are matching, so they are coinciding, and also that they are exactly on top of the microscope. For this we have a little mark made on the screen here, and as you see, it's almost perfectly matching already. If not, then you have to align the two beams by adjusting the tube lens tube here. For this we have the XY translation stage, and then you can change it slightly so that you can change the position where the beam is hitting the dichroic. What's also important is that the focus spot, when you go into the back focal plane of the objective lens, is actually in the center. So for this we have this special adapter, which you can also buy from Thorlabs. So now you need to adjust the tube lens and also the DMD's angle so that this is actually in the center. And remember, we still don't have the lenses from the telescope inserted. So if you change the DMD over here in angle, then you also change the position in the back focal plane. And so now it's in the center. And if we now were to move the objective lens, you will then see the spot at the edge, on the ceiling. And if this is roughly collimated and also in the center, then everything is set up correctly. Now we've only tried the 20x lens with lower NA, and so it's important to also have it working for higher NA, so we'll swap it over to the oil immersion, and then you see the same behavior. So in this case it's collimated, and see at the ceiling the two spots matching perfectly on one another. And again, if something is not aligned perfectly, for example the red is not on the blue, then you can slightly turn the mirror so that they are perfectly matching.